Okay, guys, welcome to our first lecture during this time of distance learning. Okay, this is going to be the lecture for my kids. This is Unit 8. This corresponds with Chapter 14, and it also corresponds with our 23rd Common Assessment. Now, things are going to look a lot different in the way everything works, so just bear with us as we work through this process with you guys. But just know that everything we do is just to give you an opportunity to continue your learning this year and to help you. Nothing we do can hurt your grade, will hurt your grade, but we still want to give you the opportunity to learn as this school year closes out to prepare you for next year, for the ACT and for the state test that is to come. Okay, so this portion of the class of biology has to do with the entire history of life, where it started, when it started, um, how we know about it in the past, and it's a pretty interesting unit to go through. So let's get right to it and look at your first objective questions that your teacher should have given you on Google Classroom already. And question 1 says, what is a fossil? How are fossils formed? And it wants you to list at least 3 ways. And who studies fossils? Well, quite simply, a fossil is any evidence of an organism that once lived. So any evidence at all. And basically there are 6 ways that we classify fossils. Again, on your objective question, it only wants you to list 3, but I'm going to go ahead and tell you all 6. So first, there are trace fossils. So this would not be direct evidence of an organism itself, but more indirect evidence that the organism was there. So this would be something like footprints, like fossilized feces, like burrows that were made under the ground by an organism. These are called trace fossils. The second kind of fossils would be molds or casts. So this is when an organism died and then was covered up by sediment, and then over time the organism itself decayed and left a gap in that sediment shaped exactly like the organism. And then that would be a mold, and then when it filled up with some other kind of hardened uh, minerals or something, then that would be a cast. So mold and cast would be the second type of fossils. The third kind would be replacement, and this is what we usually think of when we think of fossils. This is when the original material of the organism has been replaced with mineral crystals that can leave detailed, hard replicas of the bones. So when you go to a museum and you see fossils of dinosaurs or something, this is what you're looking at. The fourth type of fossil would be petrified or permineralized fossils. So this is when the empty pore spaces in the organism are filled by hardened minerals. We usually think of petrified wood as this. So the tiny holes, um, spaces that are in the wood become filled with minerals and they get very hard. Amber. So this was kind of made famous in the first Jurassic World movie. You've got the mosquito that was trapped in the amber, which is just hardened tree sap. So a mosquito landed on a tree into some tree sap and it got stuck in the sticky sap. And over time, that tree sap hardened and formed amber, and the mosquito was stuck inside of it. And so that would be an amber fossil. And in Jurassic Park, they extracted DNA from a dinosaur that the mosquito had bitten at some point. Not exactly possible, but we'll talk about that later. And then the final kind of fossil would just be original material. So if you think of like the woolly mammoths that have been discovered, usually in Russia, Siberia, they were buried in mud or something, and then covered up by snow and ice relatively quickly, and then have been covered this entire time since that happened. And so you actually have original material. You have hair and tissue and even blood found still in the woolly mammoth. So this is an original material fossil. And who studies fossils? Paleontologists. And who's your favorite paleontologist? I want you to comment on the video in Classroom. Tell me your favorite paleontologist. By the way, there's only one right answer for that. So, number 2, compare and contrast relative dating and radiometric dating, and then explain half-life. So, basically, over time, fossils are deposited and layers of rock form. And we call this the law of superposition, where the fossils that are found in lower layers are older organisms than the fossils that are found in the higher layers, because those rocks and sediment get deposited over time, and then a new layer and a new layer. And if we know the relative or the age of something in one layer, then we can surmise the age of an organism in another layer based on where it is in those layers. So we use the knowledge that we have and then how they're spaced out in layers to figure out a relative age of the organisms that once lived. Radiometric dating uses radioactive isotopes that are found in the layers to determine age. So this is a complicated process. I'll try to explain it relatively simply. But some atoms are radioactive, which means they emit radiation from their nuclei. And basically, we call this radioactive decay because the nucleus is changing. The atoms slowly turn into different atoms. And so we know now the half-life, which is the amount of time it takes for half of those elements, those radioactive elements, to decay, to turn into something else. And then we know the concentrations of the old element and the new element. And if you know those two things, and you can sample rock from a layer from some fossil record, then you can use that information to determine how old those fossils actually are. And that's called radiometric dating. All right, question number 3. What is the geological time scale? How is it divided and what are its units? So the geological time scale is just the history of the entire Earth, 4 billion plus years. And it's amounts of times that we can hardly imagine, okay? But basically, it's divided up into several different units. So epochs are the smallest units of time, geologic time, and they last several million years. Periods are the next, and they can last tens of millions of years. An era can last hundreds of millions of years, and an eon is the longest period of geologic time, and it can last billions of years. And we will get into these more as we study some things more specifically. But those are the basic units. Okay, finally, number 4. What is the significance of the Cambrian explosion and the KT boundary? So these are two very important events in the history of life on Earth that we need to talk about. The Cambrian explosion first. So the Cambrian explosion is a period of time in which most of the ancestors of organisms that live today, specifically of animals that live today, most of their ancestors first appeared in the fossil record. And it happened over a geologically relatively short period of time. We're talking millions of years still, okay? But in terms of 4 billion years, it was a relatively short period of time. And since there's so many new organisms and types of organisms in the fossil record, they call this the Cambrian explosion. Okay, and then the other one, the KT boundary, is really, really important, and it's really interesting. This is a place in the fossil record where we find overwhelming evidence of an event that created the extinction of dinosaurs, which was a meteorite hitting the Earth. So there's a mineral called iridium that is very rare on Earth, but very common in meteorites. And in the fossil record, what we find is large amounts, much larger than normal amounts of iridium throughout the fossil record at a very specific time. We pinpointed to right about 66 million years ago. And then after this layer, what we see is mass extinction. Now, our planet has undergone several mass extinctions in the course of its history. But what's important about this one is the speed at which it occurred. Mass extinctions usually take 15, 20, 30 million years. The previous mass extinctions that we've witnessed on this planet. But this one occurred in as little as thousands of years. Some estimates even say 1,000 years, up to 10,000 years, but at the most 500,000 years, which is a long time, right? But compared to 20 million years, it's not a long time. And so the evidence is overwhelming that a very large meteorite struck the Earth in the Yucatan Peninsula, which is in modern day Mexico, and caused a global catastrophe, a climate event, in which most of the reptilian type animals, like dinosaurs, were unable to survive, and it led to mammals becoming the most dominant form of land animals. And so we're going to talk more about it. You're going to learn more about it. We've got some interesting videos lined up for you this week. When you're writing your notes, remember you get points for all of this. Your grades can only go up. Last thing before I go, just know that your teachers miss you. We care about you guys. We love you. I've shared with my students already. It's just not the same. My life's not as good. As great as it is, and as much as I love being with my family, my life's just not as good as it is when I'm with you guys every day. And I know that Mrs. Bouchard and Mr. Martinez feel the same way. And finally, stay safe. Follow the guidelines. We're all about science, right? This class is about science. We look at data. We look at facts. The top scientists in the field that study viruses and epidemics and pandemics for a living, this is what they've devoted their life to. They're telling you to stay home. So stay home. Don't risk it. You may be fine, but you might spread it to a family member, and we just know that none of you guys want to do that. So as boring as it can be, it could be worse, right? So stay home, follow the guidelines. Love you guys. We'll see you next time.